Hello, you absolute legends. Welcome to Thermochemistry. All matter contains energy, and when a chemist looks at matter, the way the energy is stored, we look at a couple different locations. Not all of them pertain to Gen Chem, but there's energy stored in the nucleus of an atom, like there's a strong, attractive nuclear force holding the protons and neutrons together. There's energy in the bonds of matter, and electrons are inside the bonds of matter. There's energy in the intermolecular forces. These are the forces between molecules. So to contrast that with, say, the interstate highway system goes between states. Bonds are the highways that are within the state or within the molecule. Lastly, really the velocity of the molecule. These are four of the ways that the energy of matter is stored or released or absorbed from a perspective of chemistry. For just Gen Chem right here, we don't really think about does energy being stored and released in the nucleus, the protons and neutrons. I mean, we do talk about that just in a different chapter right here. The bonds, the energy that is stored in the bonds, and the energy that is stored in between the molecules, and the energy as a result of the velocity of the molecule are all places that we're going to be focused on. Now, because we're talking about thermochemistry, thermometer, we look at changes in temperature. So a lot of the problems and a lot of the concepts in thermochemistry are like temperature goes up, temperature goes down, how much energy was used. Or another flavor is just the opposite. This is how much energy was used. Did the temperature go up or down? And a lot of this in particular involves these two things, the intermolecular forces and the velocity of things here. Problems that occur in thermochemistry, as temperature increases, the average velocity of a molecule or all matter just increases. And think about, when I say velocity, I'm thinking about these molecules as, tiny bees buzzing. They are infinitesimally so small, so light, but nevertheless, they do have a mass, and they are moving at a meters per second, if not very long there. Now, the amount of energy that it requires to increase the temperature of matter, we have a specific unit for that, and that specific unit is called specific heat. I need to erase the board a little bit here. Specific heat is a constant of matter. Think of it as just like boiling point or melting point or density. Like the density of water is just that. You can change the temperature, but it's just just a different number right there. So it is a quantity right there, and it has some funky units to it. Its units are joules, which is energy. In the denominator, it has grams. So we're talking about the mass of matter, like how much is in there. And then we also have a temperature unit, because we're looking at changes in temperature when we talk about thermochemistry. Now, the energy, if I were to say this unit over the phone, the energy required to increase the temperature by 1 degree Celsius for 1 gram of matter. So imagine you have 1 gram of water. That's supposed to be a water droplet right there. And you had a tiny candle that would say right below that 1 gram of water right there. Okay? Now, if you had 1 gram of water which is about a thimble, and you wanted to raise it 1 degree Celsius, we know exactly how much joules or energy that would take. That would take 4.184 joules to raise 1 gram of water 1 degree Celsius. If it's 2 grams of water, it's going to take exactly twice as much energy, 4.368, 8.368 joules. I think I did that math right. Was everything good? Now the specific heat for water is 4.184 joules per gram per degree Celsius. Any number with this unit is going to be specific heat. I hope this helps. Thank you.